everyone, in this video I'm going to be working through a grade 7 past paper. This will hopefully help you as you prepare for your exams this year. Please let me know in the comments if you have any other questions. So we are allowed to use a calculator for this question unless they tell us otherwise. We've got question 1 to 10 on multiple choice, and then everything else we've got to show our workings for. So let's get straight into it. Question 1, the lowest common multiple of 5 and 7. So multiple, that's the word I always look for. So multiple, if it is a multiple, what they are really saying is the times tables. Okay, so they're saying in the 5 times tables and the 7 times tables, what is the lowest number that's in both of them? So I would just list them. So I would say, well, my multiples are 5. Remember, 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. Just list out a few. The 5 times table is really easy, so I'm sure you can all do these quite quickly. And then our 7 times tables, we're going to go 1 times 7, 2 times 7, 3 times 7, and so on, until we get a number that's the same. So here we can see we've got this number, 35, is the same. So that is the smallest number that is in both of those times tables. Okay, so the lowest common multiple of 5 and 7 is the lowest number in those timetables, and that is 35. In 6x plus 2, the variable is, okay, so the variable is always, we're looking for a letter. Okay, so our x or y or an alpha, and so the only thing in here that is a variable is the x. 32 written as a product of its prime factors. Okay, so I'm not sure how you would break this down. Usually how I break these down is I use a tree. So I go 32, I try always divide by 2, 3 or 5 to start with. So I would go 32 divided by 2, so that's going to be 2 times 16 would give me 32. I circle the 2, the 3 or the 5 because that's the prime factor. Okay, and then I've just got to keep breaking it down. 16 is the same as 2 times 8. Again, I'm going to circle that 2. 8 is the same as 2 times 4. And then 4 is the same as 2 times 2. And I just circle all of my prime factors. Okay, so that's why I try test. So I always try divide by 2, 3, or 5 because I know that those are prime numbers. And now, if we want it written as a product of its prime factors, what that means is instead of writing 32, I'm going to write all these prime factors times each other. So I would go 2 times 2 times 2 times 2 times 2. That would be my product of prime factors. And so we can see we've got C. If you were really struggling in the exam, how you'd figure this out is actually you can cross out all the ones in here that don't have prime factors. So if you have a look at this one, 1 is not a prime number, 32 is not a prime number, so you cross those out. In this one, 2 is a prime number, but 16 is not, so it can't be that answer. This one has only got prime numbers, that's why we know it's the right answer. And 4 is not a prime number, so we can't have that one. So if you're really struggling, you couldn't remember how to do that tree, just go through and try cross out the ones that you know are definitely not right. Okay, what percentage is 1,200 out of 5,000? Okay, how I like to think of these is we always work out our test percentages. Okay, so you'd always go, oh, I got 60 out of 100, and you'd work out that percentage. So you've got a calculator. So what you're going to plug in is usually you would say, okay, I got 1,200 out of 5,000. So how you always work this out is you go 1,200 out of 5,000. And if you want a percentage, you have to times it by 100. Okay, so you could put that straight into your calculator if you have that fraction function. The other way of writing it is this fraction also just means 1,200 divided by 5,000 times 100. And let's have a look at what that is. So 1,200 divided by 5,000 times 100 is 24%. Okay, question 1.5. What is the value of this expression if k is 4? So whenever they give us this, if k is equal to 4 or if x is equal to 3, that just means wherever there's a k, they want us to sub in that number instead. Okay, so we are just going to rewrite this. So we've got 3 minus k over 2. But wherever there's the k, we're going to write the 3 instead. We're going to write that 4 instead. So let's just get rid of that k. Instead of writing k, we are going to write the 4. Okay, let's try see if we can simplify this fraction before we get into it. So let's just keep the 3. 4 over 2, so 4 divided, this is the same as saying 4 divided by 2. So 4 divided by 2 is just 2. So 3 take away 2 is going to give us just 1. Okay, so my trick for these multiple choices, before you even look at these options here, just try work it out, because otherwise sometimes the options are there to confuse you. A quadrilateral in which all 4 sides are equal is called, okay, so there are 2 quadrilaterals where all 4 sides are equal. It's either the square or the rhombus. Okay, it's not a rectangle because we know not all the sides are equal there. It's not a parallelogram, and it's not a kite, so it has to be a rhombus like we said. Question 1.7, a set of points with a definite starting point and no definite end point is called. Okay, so this is if I have a set of points, so it starts here and it carries on, but it never ends, so it just keeps going. So it can't be a line segment because a line segment has a beginning and an end. A ray is to do with circles, so we're going to say that's not that one. It could be a perpendicular line, but that's not really our definition that we're going to use. So this one is actually a straight line. So it has a starting point and we don't know where it ends. Okay, question 1.8. In the above figure, WX, so this line up here, and ZY are, okay, so they are not perpendicular. They're not 90 degrees to each other. Okay, because that would look like they would be, let's see, this. It would be something more like this if they were perpendicular, which they are not like that. So they're not perpendicular. They are parallel. The reason why we know that they're parallel is because they've got that little arrow. So that arrow there always means they are parallel. They are not intersecting, so they don't ever touch each other. And they are not vertical, because vertical would be straight up. Okay, so they are parallel. We knew that because of those little arrows, so they always mean parallel lines. Question 1.9. The perimeter of a regular pentagon with one side equal to 5 centimeters is, okay, so pentagon, I always think it's like a doghouse. Okay, so it's going to look something like that. It's got 5 sides, and they're telling us each of these sides is 5 centimeters long. And they want us to know the perimeter. Perimeter is plus, so that's how I like to think of it. Perimeter is plus, so we add all the sides. Okay, so we're just going to go 5, add 5, add 5, add 5. And that is going to give us 25 centimeters. So it's as though we were walking around this pentagon. Question 1.10, the relationship between x and y is. So we're just going to test just one of these points because one of the points is enough. So let's see this first one. Sorry, didn't mean to cross that out. Let's see this first one. So we're going to go y is 5 times x. Let's check if that works. So here we've got x is 1. 1 times 5 does not give me 4, so it can't be that one. Next up, we've got y is equal to 3 times x. So 1 times 3 does not give me 4. So you're just checking, if I use this x value, do I get this y value? C, we've got y is x plus 4, so 1 plus 4 does not give me 4. And then lastly, x plus 3, 1 plus 3 gives me 4, so it has to be D then. So you're just going to work through. If it works for one point, it will usually work for all of the points. So you can just test it like that. Okay, then we get into question 2, all the workings questions. First of all, calculate without using a calculator. Okay, we can all do adding. I know you can. The important thing here, make sure you set it up nicely so we don't making silly mistakes. So let's write that big number at the top first. So 1, 6, 4, 3, 8, 8, 4. They just make it long so it seems intimidating, but you can all do this. Then this is where the lining up comes in. So let's write it backwards. So we've got 6, 0, 2, 2, 6, 2. We are adding those. We always start from the right-hand side. So 4 add 6 is 10. Carry the 1. 8 add 0 is 8. Add 1 is 9. 8 add 2 is 10. Carry the 1. 3 add 2 is 5. Add the 1 is 6. 4 add 6 is 10. Carry the 1. 6 add 2 is 8. Add the 1 is 9. And then 1 add nothing is 1. Okay, so there we go. That is our final answer. So here it's 2 marks. So you would get your marks for showing your working and then for your final answer. Okay, 6517 divided by 31. So for a question like that, I would do, we have to do the bus stop method or the garage method. So it's always the number in front. He gets to the garage first. So he gets to go inside. Okay, so 6517 divided by 31. So how you think of this is you say, how many times can 31 fit into 6? So it can't go into 6, so 0 times. Now we're trying to see how many times can 31 fit into 65. What I would usually do, if I see it's such a big division number, I would usually write down a few of them. So I would say, okay, 1 times 31 is 31. 2 times 31, I would work it out like this. So I would go 31, add 31. Okay, so that is 62. So let's check then. So it goes into 65, it goes in twice then. And the remainder is 3. It goes into 31, so this is what we're looking at next. So 31 goes into 31 one time. 31 into 7, that does not go. So then, as soon as we reach this point where it doesn't go and it's at the end, we have to add a decimal. Okay, I would just say add the decimal in any case, because you can always add the decimal and add the zeros here. That doesn't make a difference. So when I started it, I should have actually gone 6517.00. So I should have you can just do that at the start. Is just add your decimal place. Doesn't make any difference. Sometimes you don't need it. So we're going to go then 31 into 70. Okay, so we said it goes in there. It would go in there twice again because 62 is as close as we're going to get to 70. So it goes in there twice. And our remainder is 8. And then it's going to keep going like this. So I think probably you can leave it after 2 decimals. So it's going to go into 80 twice. And it's just going to keep going. So I think we can leave it at that point. So we can say our final answer then is 210.22. It's usually in the instructions, they'll tell you, okay, you can leave it to 2 decimal places. Then we've got a multiplication one. So 2.1.3, we've got 315 times 236. So a few different ways of multiplying. I'm just going to show the column method, but if you need me to show a different method, I can. So you're going to write it underneath each other, 236. Okay, so how we go is we go 6 times 5 is 30. Then we add a 0 because we're going into 10. 6 times 10, so 6 times 1 is 6. I'm going to need a lot more space here. Hang on, let me get just a blank page so you can do this. Okay, so we've got 315 times 236. Okay, I'll quickly run through those ones again. So let's use some different colors so we can see what we're doing. So 6 times 5, we said was 30. Then 6 times the 10 column, so 6 times 1, 60. And then we're working in the hundreds column, 6 times 3 is 18. Next up, we're working with the 3. So let's get a different color. So we're going to go The 3 is in the tens column, so we start by adding a 0. 3 times 5 is 15. Then we add 2 zeros. 3 times 1 is 3. And then 3 zeros, 1, 2, 3. 3 times 3 is 9. Okay, and then we finally, in the last column, we're going to go, we have to add 2 zeros because we're in the hundreds. 2 times 5 is 10. Then we add 3 zeros. 2 times 1 is 2. And then we have to add 4 zeros. 1, 2, 3, 4. 2 times 2 times 3 is 6. Okay, and then your final step here would just be adding. So we're going to go in the first column, we got all these zeros, it's just 0. This column, we got 3 add 6 is 9, add 5 is 14, so 4 carry the 1. Then 1 add 8 is 9, add 1 is 10, add 3 is 13. 1 add 1 is 2, add 9 is 11, add 1 is 12, add 2 is 14, and 1 add 6 is 7. Okay, that is our final answer, so 74,340. Okay, although you have to show your workings for this, you do have a calculator, so you could check yourself there. Okay, let's carry on. So then we've got some cube numbers. So 2 to the power of 3, that means 2 times 2 times 2, which would give us 8. You might know that immediately. And 1 to the power of 4 is 1 times 1 times 1 times 1, which is still just 1. Okay, so actually what this thing is asking us is it's going to say 2 to the power of 3 times 1 to the power of 4 is the same as saying 8 times 1, which is just 8. 2.125, the square root of 144, so that is 12. You should know that one. Okay, so it's how do I get to 144? So I went 12 times 12. And then 6 squared is 6 times 6, which is 36. Okay, so we've got 12 add 36, which is 48. Okay, then we've got some fraction questions, some Bodmas questions, some decimal questions. So when we are multiplying fractions, quite simple, we just go top times top. So we're going to go 3 times 7 at the top, which is 21. And at the bottom, we're going to go 5 times 6, which is 30. And then I don't think we can simplify that. Let's see, I don't think so. Oh, we can. We can. If you get a big number like this, you just got to check, can you divide them by anything? So these ones, we can divide both of them, top and bottom, by 3. Okay, so you have to try simplify them then. So 21 divided by 3 is 7. 30 divided by 3 is 10. Okay, so that'd be your final answer. So here you can see you would have got the 2 marks for working out, but to get that final mark, you have to simplify. Okay, then we've got a decimal question. With decimals, they like to make it seem really scary. What I would do is I would just times these both. So let's get it so that this is just 12. So I have to times that by 100. Okay, so that is just going to be 12. Actually, let's times it by 1,000. Actually, it's okay. Let's leave it. That's complicating it. What we're going to do is we draw our garage. We put the number inside. So 0.012, just like we usually would. Put the 4 on the outside. And we just got to line the decimal place up. Okay, so we go. Can 4 go into 0? No, it cannot. Can 4 go into 0? It cannot. Can 4 go into 1? Nope. Can 4 go into 12? Yep, it goes into 12 3 times. And that is our final answer there. Okay, then we've got a Bodmas question. So Bodmas, what we need to do is always work out brackets first. Okay, so let's just put Bodmas here. So first do brackets. So our bracket, if we work this out, 8 plus 4 is just going to be 12. Everything else stays the same. Next up, we don't have any of. So next up we have division. So we have to go 12 divided by 12 is 1. So 100 minus that. And then finally we have to do the adding or subtracting. 100 minus 1 is 99. Okay, write 1.6 as an improper fraction in the simplest form. So 1.6, if you said 16 divided by 10, you would get 1.6. Okay, so you can always put these over a 10 or 100, something like that. So here I would say this is 16 over 10. So you can check. Sometimes if it's a bigger number, it has to be over 100. So this is the improper fraction. They want it in the simplest form. So we have to divide these both by something. So we can divide these both, I think, by 2 probably. So top and bottom, we're going to divide it by 2 to simplify it. And so we're going to end up with 16 divided by 2 is 8. 10 divided by 2 is 5. And I think that is as far as we can go for that one. Again, so that's your 2 marks. 1 mark for writing the fraction, 1 mark for simplifying. Okay, 2.3, we've got a ratio question. A group of 25 grade 7 learners watched a soccer match. The ratio of the number of boys to girls was 2 to 3. How many boys were there? So usually I would write it like this. So boys to girls, they tell us, was 2 to 3. There are 25 in total. We want to know how many boys there were. So what you would do for a question like this is you are going to say, let's see, 25, I'm going to divide it by that added up. So that is 5. Okay, so 25 divided by 5 is 5. And then what you do is you have to times both of these parts by that answer that you get. So 2 times 5 and 3 times 5. So 2 times 5 is going to be 10. 3 times 5 is going to be 15. So we can see at this soccer match, there were 10 boys, there were 15 girls. So that is our answer there, 10 boys. Okay, I'm going to post the rest in another video, but please let me know if this helped you or if you have any questions so far, and thank you for watching.